What's up, guys? Welcome back to our first video of 2023. I don't know if you notice anything different about me, but I got this hoodie on, so there's that. We are going to be in this chapter solving systems of equations. And if you don't know what that is now, you will after today. And we're going to learn a lot of different ways. So this first section focuses on solving systems by graphing. So that's the first method we're going to use, and then we're going to learn several others. So by the end of the chapter, you'll have a lot of different ones you can use to solve a system of equations. So what is a system of equations? Basically, it's just two or more equations. We're just going to be focusing on two for now, but it's two or more equations with the same set of variables, and that's what we call a system of equations. So for instance, here's an equation with a y and an x. Here's an equation with a y and an x. Together, those are a system of equations. Now, the solution of this system, in this case, is 1050 because this point works in both equations. So something is a solution to the system if it works in both equations. If I plug in 10 for x here and 50 for y here, then we get both sides equal to each other. If I plug 10 for x here, 50 for y here in this equation, it works for this one as well. So again, a solution of a system works in both equations, and a system of equations is just two or more equations, basically. So we're going to look at solving by graphing. We reviewed graphing in class today, I guess, depending on when you're watching this, or we will review if you're watching this before class. But one way to solve a system is to graph, because if you look, we're only going to be looking at linear systems, so systems of linear equations. So if you look here, both of these are linear equations, and you should know what a linear equation looks like. And we're going to work with them most often in this y equals mx plus b form. So to solve by graphing, all we have to do is graph both lines and see where they meet. So the ordered pair that's the point of intersection is the solution of the system. So one method is to just graph both lines. Here's the y equals 5x, here's y equals 2x plus 30, and they meet at the point 1050. So this one says, point of intersection, and then number of solutions. This one is just one solution. So if the two lines intersect, they meet at one point, that means there's only one solution. And there could be no solution. If the lines never intersect, it could be an infinite amount of solutions, which we'll talk about in the second part of this section. So let's just look at how we solve by graphing. And the previous part, so this slide is on page 319. If you did not get this, you can pause here and fill in page 319, your notes. And then we are going to continue on now on page 320 with this first example. So example 1 is on page 320. So why don't you go there so that we can do this problem together, and you can create the graph yourself as well. So if I want to solve this system of equations, solving a system just means finding what point xy will work in both of these equations. And again, the way we can solve it is by graphing those lines and seeing where they meet. So if we want to graph each equation on the same coordinate plane, then we can start with our y-intercept, which in this first line is -3, so -3 is right here. Can I do that? I don't know how this thing works very well. Nope, that's not how you want to work. Alright, I'm just going to draw it like this. So the equations are y equals 2x minus 3. So we're going to start at -3. And for this one, you might want to, the slope is -2. So from here, we would go down to right 1. But I'm going to do that a few times. Go down to right 1 again. And I'm actually going to go up to left 1. So I'm going to make several points on here when I make my graph, because you want to make your graph really good with this method. Otherwise, it's not that easy to work with. And then the other equation is 2x plus 5. So here's 5. I would go up 2 over 1, up 2 over 1. And I'm also going to go down 2 over 1, down 2 over 1. And the reason I do that is that if I do this, again, my graphs are not perfect, but if I do that, I can see that right here at -2, 1, this stylus does not want to work for me, sorry, this is -2, 1, if you can read that, that should be a 1, is where these two lines meet, okay? So -2, 1 is, when I graph both those lines, where those two lines intersect. And then we can check that answer by plugging it in. So -2, 1 is where it looks like they intersect. I'm going to replace x with -2 and y with 1, and we're going to do that in both equations. And if we do that, this is 1. You're not going to work, okay. It doesn't just let me write the number 1. 1, there we go. And -2 times -2 is 4, 4 minus 3 is also 1. So this is 1, and this is 1, and this also equals 1. So all of these work, or this works in both of these equations. So this is the solution to this system of equations. Okay? So here's just another one really quick we can do, if you just want to follow along with this one. So y equals x plus 1 is the first equation, and y equals -1/4 x plus 1 is the other equation. So y equals x plus 1, 1 is the y-intercept, we would go up 1 over 1, down 1 over 1, left 1, and create our graph. And then the other one was y equals 1/4 x plus 1. I think -1/4. So we would go down 1 over 4. But you can see in this case, they both have the same y-intercept. So that's where they actually intersect. So my solution is the point 0, 1, because both those lines cross. So you're just graphing both lines. So the graphing is a review, and then you're just seeing where they intersect. And if I check that point 0, 1, if I plug 0 in for x and 1 in for y, we'll see that that works in both of those equations. So 0, 1 is our solution for this system. Okay, so why don't you guys try the check problem at the top of page 321. See if you can graph both those lines. And it might help to use like a ruler or a straight edge. And like I said, make several dots on your graph so that you can have a better graph there. And it's easier to find exactly where those 2 points intersect, or those 2 lines intersect. Okay, so here's another one, and this is example 2 on page 321. Now, if you remember, it's been a while, well, I guess we are going to talk about this in class before you see this video. So if you want to graph a line where it's just x equals, what kind of line is that? Yes, a vertical line. I'm just going to pretend I hear you saying the correct answers. And this one, y equals -6, is a horizontal line. So this is still a system, okay? Even though they don't both have x and y, we can still think of this as a system of equations. So we're going to graph each of these in the coordinate plane. And the line x equals 3, we go to 3 on the x-axis. And let me just, 3 on the x-axis, and draw a vertical line through that. So this is the line x equals 3. And then for the horizontal line, y equals -6, I'm going to go to -6 on the y-axis and draw a horizontal line through there. And with these, it's pretty easy to tell where they intersect. They intersect at the point 3, -6, which should make sense. The x-coordinate would have to be 3, the y-coordinate would have to be -6 there. Okay. So then the next part for this one is again to just kind of check and analyze the solution. So since x is equal to 3 and y is equal to -6 already, I mean, we kind of don't even have to draw the line because we know that x is 3 and y is -6. So 3, -6 makes sense as the answer. Now we did this part in class, so you should have this filled in on page 322 already. So I'm going to skip to page 323. learning systems of equations with no solution. So we said that a system, the solution to a system is where the two lines intersect. Well, what if the two lines never intersect? Then they would be parallel lines. And if they're parallel and they never intersect, then there's no solution. There's no point that's going to work in both of these equations because these lines never meet up. So the point of intersection, there is no point. The solution, there is no solution. So if two lines are parallel, there is no solution. Now, an important thing to note is that when you start solving the system, there's a few ways you can tell that there's going to be no solution. We're technically not getting into this yet, but we want to start by, well, we'll start with writing both of these in slope-intercept form. So notice that this one is already in slope-intercept form, but this one is not. So to get it in slope-intercept form, we need y by itself. So we'll add 2/3 x to both sides. Again, we kind of practiced this in class already. So I'm going to move this over. We cannot combine these. They're not like terms. So we're just going to write them in this slope-intercept form. So you can just put them next to each other. This is fine, but if you want it to be in slope-intercept form, then we'll put the x first and then the constant last. So now that they're both in slope-intercept form, then we're going to graph both of them. Now we have y equals 2/3 x plus 1 and 2/3 x minus 3. So 2/3 x plus 1 is right here. I'll go up 2 over 3. And there's that line. And then minus 3 is the next one. Go up 2 over 3. And there's that line. And you can see if you graph it well, especially with the straight edge, I can't really do that on the screen, but you can see that those lines are parallel, they'll never intersect. But what do you notice about the equations of those lines? See anything there? Notice anything at all? Okay. So if you look at these, they both have the same slope but different y-intercepts, okay? And we said that these have no solution. So if we were to kind of rewrite this equation so that they're both in the same form, like the first equation started out like this, if I rearrange it to look like this, then you end up with the same thing on the left-hand side, but two different numbers on the right-hand side. So this is another way you can see there's no solution. Or if you notice that they have the same slope, any parallel lines have the same slope but different y-intercepts. So if the two lines are parallel, they're never going to intersect. That system is going to have no solution. Okay, so you can stop here for part 1 of the video, and that's all you need to know. Actually, but try the check problem at the top of page 325. So do the checked problem at the top of page 325, and then that'll be the end of part 1. Okay, so now that you have unpaused, let us begin part 2 of this video. Welcome back to part 2 of section 6.1, where we are going to look at the last part, which is systems of equations with infinitely many solutions. So here I have two equations, y equals 3x plus 5 and negative 3x plus y equals 5. So two equations, but when I graph each of these, it's the exact same line. So this system, when it's the exact same line, when you have two equations, but they end up being the exact same line, where do two equations that are the exact same line intersect? Well, they intersect at every single point on this line. So there's an infinite number of solutions because any point on this line works. So that is a case where there's infinitely many solutions, when the two equations actually end up being the exact same line. Now, what you're going to see when you're solving these is that when you rewrite them in slope-intercept form, you actually end up with the exact same equation. So here's two equations. We want to start by writing them both in slope-intercept form. So this one already is, and this example is on page 326. So this equation is already in slope-intercept form. We have to rearrange this to get it in slope-intercept form. So all we have to do is add 3 to both sides. And if we do that, we end up with, this makes me angry. 2x plus 1 plus 1. So what do you notice? Here's one equation, and when we simplify the other equation, it's also y equals 2x plus 1. So when that happens, and we graph them, if I'm going to graph each of these equations, I'm graphing y equals 2x plus 1. Here's 1. Here's the y-intercept of 1. Nope, if it lets me. And then I go up 2 over 1. But this equation, when I rewrite it, is also 2x plus 1. So I start at 1, go up 2 over 1, and graph that as well. And let's just pretend I graph these perfectly. These lines would pretty much overlap with each other, and they would intersect at every single point on this line. So this system has an infinite amount of solutions. So there are three things we looked at. We had systems with one solution, and that's where the two lines intersect at some point. We have systems with no solution, and that's when the two lines are parallel to each other and never intersect. And then we have systems with infinite amount of solutions where you have one on top of the other. So they would intersect at every single point on each of those lines. So those are the three different options, and we're going to look at solving systems using different methods, but you'll see the same thing happening. There's either one solution, no solution, or an infinite amount of solutions. So try the check problem on the bottom of page 326, and we will go over it in class tomorrow, and you guys have a great night. And hey, let me know if you want the number of my stylists so you guys can get awesome hair like this. All right, good night.